In this, our last episode of Citizen Science versus the Aliens of Peru, Jackson and I will measure the volume of an elongated skull and compare it to that of a normal human skull. We do this to test the claims made by Brian Forrester and Gaia.com that the elongated skulls are 25% larger than normal and are therefore non-human. In this video, you will learn about volume, cubic centimeters, and a simplified version of Archimedes' principle. Most importantly, you will learn how to use science and critical thinking for yourselves to test the claims of conspiracy theorists on the internet. You are watching episode 5 of Citizen Science versus the Aliens of Peru. Welcome everybody, this is the episode you've all been waiting for. I am here with my nephew,
Jackson. Hello, people of the internet.
Yeah, this is the exciting episode. This is where we're going to actually measure the volume of these skulls. And we're going to see if the volume of the elongated skull really is 25% larger than the volume of the normal skull. If it is 25% larger, I will be intrigued. If it's not, I'm going to say that this is just a normal human, most likely a normal human, with head binding, right? So, Jackson, do you want to tell us what volume is versus weight?
Volume
do you know?
Is, I only know volume, that's it. But volume is how much something takes space. Like
right.
How much space something takes.
Exactly. Volume is how much space something takes. So I have here, what is this?
Cubic centimeter.
This is a cubic centimeter, roughly. I just made this out of clay. And we measure volume in cubic centimeters. Sometimes we measure it in milliliters. They're actually the same thing. Usually when we're measuring liquid, we measure it in milliliters. We just like to call them liters instead of centimeters.
Yeah, most of us don't use the metric system.
Yeah. In science, we use the metric system. Yeah. We measure volume in milliliters. And so if something is 500 milliliters, that means it's 500 of these little cubes. Yeah. And that's how much space it takes up. And grams, 1 milliliter of water, or 1 cubic centimeter of water, weighs 1 gram. Gold weighs more than 1 gram. And because of that, when you put gold in water, it sinks.
Tell them the story about the guy who figured out volume.
Right. Archimedes is the man who figured out how to measure the volume of irregular objects. So we're trying to measure the volume of these skulls. That's hard to do because, you know, with this, you can get a ruler and you can measure, it's 1 centimeter by 1 centimeter by 1 centimeter. Yeah. Oh, that's 1 cubic centimeter. But it's really hard to measure with a ruler something like this. It's an irregular shape. Archimedes, this was over 2,200 years ago. Yep. He discovered this. So he was actually alive probably when this, maybe when this person was alive here. Because this elongated skull is 2,000 years old.
Wasn't it like a native person?
Yeah, in Peru. And we don't know exactly the date on this, but we think somewhere 2,000 years old, or maybe slightly older. Yeah. So she might have actually been alive at the same time as Archimedes. But Archimedes, he was a scientist way back in the day. Yep. If you could call him that. He's a philosopher, and he figured out lots of stuff. And there's this thing called Archimedes' principle, Archimedes' rule. You can measure the volume of an object by setting it in water. You take a dish, you fill it to the very top with water, then you set an object in it, and the amount of water that spills over, you can then measure with something like this that actually has lines to tell you how many milliliters it is. And the amount of water that spills over is the exact same as the volume of the object that you dunked in that water. He figured this out by getting into the bathtub. The story goes that he figured this out by getting into the bathtub and watching the water rise. And he was really excited about this, because the king had a crown made by a goldsmith. Yep. And it was supposed to be made out of gold, but the king heard a rumor that the goldsmith mixed silver in with that gold.
He wanted to keep the gold to himself.
And the king was really upset about this, but he loved the crown. He didn't want to melt it. What you could do is you could weigh the crown, because they already knew how much gold weighed per cubic centimeter. So you could melt down the crown into a cube and then measure it with a ruler, see how many cubic centimeters it is, and then weigh it and see if it actually is pure gold or not.
But since he liked it so much, they didn't know a way to do it. So then this guy who was in the bathtub You can continue the story.
Yeah. Yeah, so they didn't want to melt the crown to measure it. But this guy, Archimedes, who's in the bathtub, he noticed how this works. And he got so excited, he screamed, "Eureka!" And he started running down the street naked, just really excited about his discovery. That's the story. We don't know if it's a true story, but yeah. Yeah. So they figured it out. They measured the crown, and the crown was, in fact, too big for how much it weighed. That means that there was silver added to the gold.
And then let's just say the guy who made it had a terrible ending for himself.
Yeah, I don't think things ended well for the goldsmith that lied, right? So, yeah. That is the principle that we're going to be using to measure these skulls. We're going to dump them in the skulometer 3000, the skulometer 3000, and we're going to measure how much water comes out when we dunk in these skulls. What I've made is I just put a tube right in here. We're going to fill the water all the way up to that tube till it starts to spill out. And we're going to let it spill out completely. That's going to zero our machine here. That's going to, once it's all the way filled out, that's going to tell us that the water is right at the spill line. Then we're going to take these skulls and we're going to, one by one, dunk them in and then measure on here how much volume we get. So this is our experiment. And the reason that we're doing this experiment, Jackson,
is to prove, I think there's a guy online, I forgot his name, but he thinks that this is 25% larger, like he said. Mm-hmm. Or he says it could be an alien or like an angel thing.
Yeah. Well, he's not saying that it's an alien or an angel. He's just saying that it's 25% larger than a normal human skull, and he says that because of that, it can't be human. It can't be a normal human. And he's done a lot of videos about this, and he's actually, I don't want to pick on him too much. His name's Brian Forster, because he's actually getting a lot of people excited about paleontology, and that's a good thing, right? But he's really excited, and he's jumping to some conclusions without carefully examining things that are a little bit scientifically irresponsible. But that people get excited, that's fine. So he says this is 25% larger than a normal human. I suspect, so he actually measured one. What he did is he took rice and put it into the big hole at the bottom of the skull and filled up the brain cavity in one of his skulls. And he did the same with one of his normal skulls. And he said that the elongated skull was 25% larger. What I suspect happened is that he had an abnormally small normal skull that he was measuring. These two skulls, they are perfect casts made from real skulls. This elongated skull is actually the one that Brian Forster puts on the cover of his book. Yep. It's a really famous specimen. It's one of the most extreme ones that's out there. And this skull comes from a normal human. And Bone Clones is the company that made these. And Bone Clones chose this guy's skull to use because he was a really typical human. So this should be a normal-sized skull. And this, we don't know. We don't know, right? It certainly looks longer.
It could be one more plus, and that'd be considered that one's like a little bit bigger.
Yeah. Now, there is normal variation between humans. So if one of these is slightly bigger than the other, that's not really that big of a deal. But if one of them is 25% bigger than the other,
pretty much like 100 plus.
That's a big deal. A good scientist will demonstrate all of their experiments so that other people can repeat this at home.
If they think that we're wrong.
Right. Because sometimes in science, what we realize is that sometimes people will trick themselves into believing something that's false. So on the front of this bucket, we have this phrase, nullius in verba.
Isn't it like something from England that scientists use?
Yes.
To say?
That's the saying from the Royal Society, which is one of the oldest scientific clubs, you could say, that is in existence. And that saying means take no one's word. Take nobody's word for it. In this scientific club, whenever someone made a claim, they had to show every single piece of data that they used to come to that conclusion so that other people could read their paper and say, yeah, I agree, or no, I don't agree. And they had to document everything so perfectly that anyone could replicate their experiment. So that's what we're doing here with this video. This is all easy. Anyone can do this at home. All you have to do is buy these skulls, these skull replicas, which you can buy from Bone Clones.
How much are they?
They're kind of expensive. I think this one's like $200. Yeah. And this one is like,
if you're a rich millionaire, you could do this.
They're really cool though, because these things are perfect replicas of the original. Now, when we say take no one's word for it, one of the problems with using replicas instead of the actual skulls is that we're actually taking the word of bone clones, right? We're kind of trusting them, right? So that's one of the weaknesses in this. But bone clones, what they do for a living is they make skulls that are perfectly accurate. That's what they depend on. It's their bread and butter. So we have no reason to suspect that they would have modified these. But that is one of the things that is a weakness in our experiment. And talking about the weaknesses of an experiment is what the people in the Royal Society do as well. When someone's actually trying to do real science, they will be very clear with their audience about the strengths and weaknesses of their experiment. What do you think is maybe another possible weakness of our experiment?
So everyone has a special kind of made skull. This one is just a different kind of skull. No one else would have that kind of same structured skull.
Right. Everybody's unique, right?
Yeah, in their own way.
So if we wanted to really do good science, we will want to do more experiments with more skulls. But for a YouTube experiment, I think it's okay just to use 2 skulls. But ideally, we would use hundreds of skulls. We would use hundreds of elongated skulls, hundreds of normal skulls, and we would get the averages. And those would be what the thing we would really care about. But, for this experiment, I think 2 should be enough. The other slight weakness in our experiment is that we cannot measure the inside of these skulls because these are just casts, and the inside of the skull was not perfectly made to match the original specimens.
Yeah. So we had to, block it up, didn't we?
Yeah. Yeah, what I did is I blocked up all the holes in the skull. You have lots of holes that, like your eyes, there's a hole where it goes back into your brain. And I plugged up all those holes with clay. It's actually this stuff, which is a gummy eraser that you can get at an art store. So I plugged up all the holes with gummy erasers. And I also filled them with sand so they'd be really heavy, so they'll sink in the water. And the disadvantage of that is that we're measuring not just the brain, we're also measuring the teeth and everything. And she's missing a couple of teeth. She's missing 4.5 teeth. Oof. And I've calculated that that's about 5 cubic centimeters. So we're going to have to add 5 cubic centimeters to whatever data we get from her.
Put that in your notes.
Yeah.
So you don't forget.
So that's one of the disadvantages. The other disadvantage to that is that all of the data that this other guy, Brian Forrester, has done, he's been measuring the insides of the skulls. So we won't be able to compare our data directly to his, but we will be able to tell if this is 25% larger than this one. That will come through in this experiment. Unfortunately, also, when other scientists do brain volume experiments, they measure the inside of the skull. So if we go back to the literature, the scientific literature, and try and compare our numbers to theirs, our numbers are going to be different because we measured the whole skull, not just the inside of the skull. So there we go. I think we've covered our strengths and weaknesses of this experiment. Everybody now knows how to measure volume, the volume of an irregular object. So let's zero out our machine, the Skull-O-Meter 3000, and let's get doing our thing. Do you want to film me do that?
Yeah.
We want to film things from every angle so that people know that we're not cheating here. Just fill it to the line. I don't want it to be shaking much. If it starts shaking, the measurement can actually be inaccurate. If there's waves in the water, the measurement can be inaccurate. This isn't an absolute perfect method because the water has surface tension.
Yeah,
and that can cause a little bit of problems. But we should be accurate within a few cubic centimeters. Our cup here has a line every 20 cubic centimeters. So our measurements will be within 20 cubic centimeters. That's how accurate they'll be. It takes a while for this to trickle out. It sounds like it's taking a pee, What are we missing, Jackson?
You know what time it is.
Yeah, it's white coat time. All right.
What the heck?
Here we are. We are now... got some bunch in there.
Yeah, well, the problem is you snapped and this came on, and this is an adult size.
Okay.
And I'm not an adult.
Okay, there we go. That's... All right, we are science-ified. We can now be trusted by the people that like to watch Gaia. Videos on Gaia.com. By the way, we should probably charge them $10 a month for watching our show, because that's what Gaia charges their people for their lies and mythology.
Yeah.
And we're doing actual legitimate science. We should actually charge them more than $10 because our stuff's real. All right. So which one should we measure first? Should we measure?
Let's measure the human one.
Okay.
Because
Now,
that seems right.
to make it so that the camera can easily see the liquid, we're going to do 10 drops of this.
For the human.
For the human. 10 drops of blue. That way it's going to be easy to see when the water fills in here. Do you want to do that?
Yeah. Here?
Yeah. Do it slow so you can count each drop.
Oh, jeez. I can't. 1, 2. I can't do this.
Here, I can do it. All right. That is 10 drops of blue, just to make it easier for people to see. And
now for the skull. You might want to show the block up, so. Oh.
Here it is, all blocked up with this clay. It's actually rubber eraser. And let's film this. Film what I'm doing here, dunking it in. Yeah, show the skull too. I'm going to block the nozzle real quick so that I can drop this in all the way, because what's going to happen is I got to put my hand in for a second, and I don't want my hand to be measured. So I'm trying to gently put it in there so there's no waves. And now that I've done that, I'm opening up the nozzle again. What is our measurement?
Starting to slow down. It's about 140-ish. 1,400-ish. And it's getting taller. Oh, there's bubbles.
Yeah, there's bubbles. I think there might be a tiny bit of water getting into the skull.
But,
So that's going to make his volume a little bit less than it is in real life. But I think we're okay.
Or
because it's so slow. We're almost at 1,700. That middle kind of medium line is 1,700.
Come on, just a few more drops.
Almost done dripping. It's always so slow, isn't it? At the end.
It's done. And look at that. At least in the middle of 1,600.
Yeah, so that line right above it is 1,700.
So you just have to add like...
We're at about 1,600 and looks like 90 because each one of these lines is is 20. So we're at about 1,690 for the normal human skull. We're right in between those two lines. 1,690 cubic centimeters.
Yeah.
Approximately. That's as close as we can get in this
right,
with our measuring tools here.
Should have put that into there.
Yeah, let's show this to people. This is the normal human skull. That's how much volume that normal human skull is.
Should we fill it up with the extra water? A little?
Yeah, we're gonna zero out the machine again. Our beaker.
It'd be crazy if they're both the same, they'd be both the same milliliters.
That would be crazy, huh?
Yeah.
My suspicion is that they're going to be fairly close. But he says that the elongated skull is 25% larger than a normal skull. So let's do some math while this is trickling down. Let's do some math and figure out what 25% larger than 1,690 milliliters would be. Do you know how to do that calculation?
Isn't it division involved?
No, you actually just, you do this number times 1.25.
I don't know that.
What's that?
I don't know that.
No. Well, we'll just use a calculator. So,
We got technology with us.
1,690 times 1.25, because 0.25 is 25%.
Yeah.
And 1 is 100. So we want the normal skull plus 0.25.
Yeah.
So we do it times 1.25. That's the logic there. And that equals 2,112.5
That's over
cubic
that.
centimeters.
That'd be like
Yeah.
right here.
Yeah. So if the long skull really is 25% larger than the normal skull, it will be 2,112.5 milliliters. Now, our measurement device isn't that accurate, so I would say that if we get to at least 2050, I'm going to say this is significant. We need to look further into this, okay?
Yeah.
So I'm going to be generous and say if we can get to 2050 milliliters.
That seems, yeah.
I'm going to say this is phenomenal. This is really cool. That's our target. Hopefully.
Yeah, that's our estimate we're wanting to get to.
Hopefully she is that fantastic, and then we'll have to explore what the heck kind of what's going on, you know?
Yeah.
Okay, so this is still going here. If we do find that she is 25% larger, does that automatically mean that she's an alien or an alien hybrid or what, or something?
Not really.
Why not?
I don't know.
Well, we learned before that humans can have a whole variety of head shapes, right, and sizes. So maybe she's just a really big-headed person. Yeah,
their tribe could have been, like, with females are taller than men, probably.
But, it would be pretty interesting if she was that big, because they say that, there are lots of these skulls and have lots of them that are that big. If she was that big, we'd want to start comparing all of the skulls that are there in Peru, and we want to see if all of them are big. And if all of them are big, that's interesting.
Yeah.
Maybe they have some sort of genetic difference that makes them larger than normal humans. Maybe the cranial binding somehow actually makes the head bigger. That wouldn't make sense.
Yeah.
Because
they just put like a stone board on the person's head.
Yeah. Well, in this case, they would use they'd bind their heads with fabric. We think there's some artifacts that suggest that they did that. So we don't think that should make their head actually bigger. We think it should making it longer, yes, but not bigger. We think it should make it longer, but also narrower. So. Because the brain will grow until it's done. The skull will grow to fit the brain as it's growing. So once the brain's done growing, the skull will stop growing. So this should be normal sized. It should be. It should just be misshapen. Yeah, so this is our machine is zeroed. I'm going to dump this out in our excess water bucket. I'm going to try and get all the drops out. Close I can. It's not. And we're going to do the same. We're going to make her purple. So I'm going to do 5 blue drops and 5 red drops because we did 10 blue drops last time.
I'll do
these. All right. That should come out purple. That'll be cool. Here we go. That I've plugged her holes in the same way. So her nose is still open just like his was. We talked briefly about her missing some teeth.
So we'll just add 5 more.
Yeah, we're going to add 5 milliliters. Actually, maybe 6 milliliters because her teeth are also a little bit ground down compared to his. She might have been older. It's working.
It's black.
It's making purple.
Kind of.
Yeah. It'll get more purple when it's more watered down.
Can't see the purple edges.
Okay. Now, once again, I'm going to plug this because I'm going to dunk even my whole hand in here to make sure that she's set in there nice. I'm going to wait till the waves go away, and then I will unplug it. And that's good there. Now we have started again. Oh, man, this is suspenseful. What's it going to be? Is she going to really be over 2,000 milliliters?
Which is like...
above our measuring, yeah.
Probably won't, because look how it's kind of slowing down.
Yeah, it's already slowing down.
Although if it makes it up to about where we were, kind of like, it wouldn't really be that much of an improvement.
Yeah, last time we were at 1,690. Here, hold that a little bit more stable so people can see. 1,690 is what we were at before. Let's see if we get there. It's already slowing down, but it keeps going quite a bit after it slows down, so she might be bigger than he is. Our purple alien.
Shut over here.
Oh man, this is exciting. Oh, and there's no bubbles. That means there's no water leaking into her skull.
That's good.
That's good. That's given her a little bit of an edge over him. He had probably a couple drops that got into his skull. Not much, but a couple of drops got into his skull. So that means they were lost in the measurement. So our measurement was slightly less than it should have been, but not much at all.
It's almost at the 1,600 mark.
Okay. Well,
A little bit of water.
that's pretty close.
There's a little design. You can see like the little water thing going through.
Yeah, that's cool.
What kind of tube did you use, man?
Just a plastic tube from Home Depot.
Oh, well, that.
Look at that. It's slowing down. It's not. Oh, here, zoom in on this thing, on the tube. We can watch those last drips. It's still going. Still going. Be careful not to bump the table. What are we at? What are we at? Oh, man. So suspenseful. Oh, we're way lower.
Yeah. Uh-oh.
Huh. There's no bubbles coming out of her? Yeah, look. Show the audience there's no bubbles coming out. So there's no leaks. Be careful not to shake the table. There's no leaks.
At all.
That means she is actually smaller. Let's wait. Oh, we're done. We're done.
She's smaller.
What is she at? She's at 1,600 and, each one of those lines is 20. So 1,620, 40. 1,640 milliliters. And a milliliter is cubic centimeter. Same thing. Dang. She is not an alien.
+5. Well,
Oh,
6.
+5. +6, yeah. So 1,646, and he was 1,690. He's bigger.
That also could be that she's a woman, and since women are, like, their heads are a tiny bit smaller, and men are usually have bigger heads, that could be why.
Right. We have noticed, if you look at all the experiments on head size, we have noticed that men, not always, but typically have a slightly larger head than women. And the reason for that is that men are taller than women. It's one of the reasons for that. And the taller that you are, the bigger your head is. Yeah. So this is actually not very surprising that he was slightly larger than hers, but it is surprising because it means that there's no reason to think that she's an alien.
Mystery.
There's no reason to think she is just a normal person that had cranial binding on her head. That is the most likely conclusion. She looks bigger, but that's an illusion.
An optical illusion.
Yeah, put that in there. So there you have it, folks. The Paracas skulls are not larger than normal human skulls. At least this Paracas skull is not larger than this normal human skull.
Because we don't have hundreds and hundreds.
Right.
Although that would have been a lot of money.
Yeah.
Unless you're the guy who made Amazon, that'd be spending like, what, $1?
Yeah.
It feels like
well, the company that makes these only has, I think 3 elongated skulls that they've made. Because they have, in order to make these skulls, what they do is they actually take the specimen, they use it as a cast, and then they have to give it back. So you have to ship the skull across the world.
Actually, you could put this into a link where you could see the you could press on the video if you see it.
Yeah.
So.
Yeah, we're gonna have in the video description. We will have a link where you can see how Bone Clones makes their skulls. You'll see them; they're actually doing a saber-toothed tiger in the video. And you'll see how that process works. I would say that this myth is been debunked. I don't think that there's no reason to suspect that she is an alien.
She's just a normal human.
Just a normal human.
With a weird head.
With a weird shaped head.
Yeah.
Because it was bound when she was a baby. That's incredible. Look at this. It really is impressive to know that this amazingly bizarre shaped head was produced by simply binding the skull of a baby. That is incredible. So while it is sad that she's not an alien, we can still be happy with this. This is amazing. It teaches us so much about how plastic living creatures are. We grow to fill the space that we're given. That's amazing. And to think that she lived to adulthood, so obviously if there was brain damage caused by this, it wasn't severe. She lived to adulthood. So, pretty incredible specimen. Any final words of wisdom, Jackson?
Nope, not really.
Take no one's word. That's what I'm going to say. Take no one's word. I mean, that's a little bit cynical. When doing science, take no one's word. Obviously, you can trust your friends and neighbors unless they tell you something crazy, like that we found aliens in Peru. But, yeah. So long for now. Do you know the tagline?
Keep
trucking. Stay curious.
Stay curious.
So long for now.
Stay curious.
Yeah. All right. High five, Jackson. That was fun. You took off your gloves? Now the Gaia people aren't going to trust you. They're going to think that you lied to them. Great.
Well, you did say in the video.
All right. We did it. We made a great show.
I'm surprised that this one's actually smaller.